Yes, very good morning, very good evening, very good afternoon, whenever you are watching this. So, first we have completed hydrocarbon part 1 and hydrocarbon part 2. And I hope up to that you have understood each and everything. Now we are going to see hydrocarbon part 3, and the topic name is reaction of alkane. And this topic is one of the big topic that I have to cover, but again I am saying, without completing all this hydrocarbon, don't leave, because time is very less we will have. Now, reaction of alkane. In this, first of all, we have to know the first topic, and the name of the first topic is called substitution reaction. Substitution reaction. In that substitution reaction, first we have to study halogenation reaction. After halogenation, we have to study nitration. After nitration, we have to study sulfonation. And after sulfonation, we have to study Reed's reaction. So this is the first and foremost topic of alkane, that is substitution. After completing substitution, we will go with the next part of the topic in alkane only. Substitution has that subtopic, and the second topic I will teach you isomerization. After completing isomerization, third topic I will teach you, and the name of the topic is aromatization. After completing aromatization, fourth topic I will complete, and the name of the topic is combustion. After completing combustion, I will teach you fifth topic, that is called pyrolysis. And these are the total topic present in the reaction of alkane, in which halogenation is most important topic. If you will understood this, then remaining topic is one line, not that much big, but halogenation is one of the biggest topic in all of the topic, and halogenation belongs to substitution. Where it will belongs? Substitution. So now in this video I will try to complete all the reaction of alkane. You have seen it? Yes sir. Then next topic I will, next video, next topic, like that we will see. First we are going to start substitution reaction. In that substitution I am going to start halogenation. It means first important topic is substitution. And again I am saying, just read out and see the things very properly. Don't get nervous and confusion. Now, so reaction of alkane, substitution, halogenation we have started. These are the topic that we have to cover. In that, first I am going to start substitution. Just listen it very properly. Don't get nervous and confused. In substitution, first topic I will start halogenation. Now, halogenation, first of all, it is a substitution reaction. Halogenation is a substitution reaction. Halogenation means what? Halogenation. Hydrogenation means addition of hydrogen. Halogenation means addition of halogen. What is halogen, sir? Halogens are fluorine, F2, chlorine, Br2, bromine, I2, iodine. These are the halogen. So we are going to see the addition of halogen in halogenation of substitution method. Now, over here, what is the reagent we will use? First of all, so the reagent that we will use is X2. X2 means either F2 or Br2 or Cl2 or I2 in presence of H mu or photon or sunlight. The light of sun is known as sunlight. They will release one energy, the particle, that is called photon, and it is also denoted by h mu. So all three have the same meaning. Over here, in place of Hx2, you will take Cl2 in presence of h mu, photon or sunlight, or you will take Br2 in presence of h mu, photon or sunlight, or you will take I2 in presence of h mu, photon or sunlight, or you will take F2 in presence of h mu, photon or sunlight. This we have to do. Now, first reaction we are going to do. Suppose we have taken CH4 and I am trying to react with Cl2. Understood this part? Whenever any question coming, Cl2 is given excess or not given excess. Suppose Cl2 is not given excess, simply they have given Cl2 in presence of h mu, or instead of Cl2 I will write directly x2. Any problem? When I will write x2, you are able to understand what I am trying to say. So I am writing over here x2. In x2 means Cl2, Br2, F2, I2 in presence of h mu or photon or sunlight. What is the product coming? The product is coming CH3x plus HX. But the problem is that this reaction will not stop here. It will go on continuing, means again some X2 will be left, that X2 again react and it will become CH2 X2 plus HX. Again it will react with X2, it will form CH X3 plus HX. Again it will react with X2 and it will form CX4 plus HX. Means problem is that this reaction will do substitution. This reaction will do substitution until and unless all hydrogen will be replaced by halogen. All hydrogen will not replace by halogen. Up to that this will do the reaction. But someone will say, no sir, I have to stop the reaction over here. What I will do in that? So sir, in this case, what you have to do? You have to do this reaction in industries. This you are understood, don't get confused. First I have written reagent is this. Whenever you are reacting with X2, na, what happens? If you will going to do this reaction in laboratory, what is the problem coming? Each and every halogen will remove all hydrogen until and unless all hydrogen will not go and all halogen will not added. This reaction is going on continuing. So from here you will write, it is not an laboratory method. It is not a laboratory method. It is not a laboratory method. This reaction you can't do in laboratory. It is an industrial process. It is an industrial process. What will happen in the case of industry? We have lots of machine. That machine will stop the reaction. Whenever you are doing X2 in presence of photon or sunlight, this will stop the reaction up to CH3X plus HX. Further reaction they will not allow to do. So it is an industrial process. It is not a laboratory process. If you will do laboratory, what happens? All the hydrogen will go and all the halogen will come up to this. So we will need up to this only product. So we will have to use industry. Now this reaction of halogenation, this reaction of halogenation follow free radical mechanism. Which reaction it will follow? Free radical mechanism. Sir, how you know that it is free radical mechanism? So understood, whenever they will write help or helper, these all will follow free radical, means high temperature, like any place written 500 degrees Celsius, 200 degrees Celsius, some high temperature is given, you have to understood this is a free radical mechanism. If any place written electricity, So you will say it is free radical mechanism. Any place written light like H mu, photon or sunlight. So previously it is written what? H mu, photon or sunlight. Then again you will say it is a free radical mechanism. Any place written peroxide. Peroxide like either it should be H2O2 or it should be C6H5CO whole twice O2 and O or O2, or any place written Kheras effect. Kheras effect. These all are known as peroxide, or any place direct radical written. Radical written means CS3 dot, CF3 dot, any dot type of things is there, then it will do also free radical mechanism. It means these are the process by which you can judge it is doing free radical mechanism. Understood up to this? What I am dictating, nothing extra. These are the topic I am going to cover. Substitution, addition of halogen, halogenation. X2 if you will do in laboratory, it will remove all hydrogen and try to produce up to which all the halogen will not go and hydrogen will not go, halogen will not come. Up to that the reaction is going on. Over here if you have to stop this reaction, you have to go into the industry. So it is the industrial method. This reaction, how we will know that the previous reaction is doing free radical mechanism? So if this condition coming, then you will say it is the free radical mechanism. Now I am going to dictate you what is happening in free radical mechanism. How we will understood what is free radical mechanism. Understood point? Everyone understanding? Don't get confused. So I am saying na, watch once. Any confusion, I am giving each video, I am giving this number. Those who are watching this video from the beginning, 9267937718, you can WhatsApp me on this number. I will try to dictate you if any confusion is there. I am not here to become the superstar on YouTube. I am here to become the superstar in the eyes of some student, those who are studying and trying to get the marks over here. Okay, so try to see the things very properly. Any confusion you can ask on this number. Now, free radical mechanism happens in 3 steps. First step is known as chain initiation. What happens in the case of chain initiation? You have to take any X2. X2 will be like X and X, and that you have to show them the sunlight, H mu, photon or sunlight. When you will show them sunlight, H mu or photon, means it is not like that you have to do all this reaction in sunlight only. You have to just see one light to chlorine, bromine or iodine. It will do hemolytic cleavage. You know that this types of cleavage is homolytic cleavage. Due to homolytic cleavage, what you will get? X dot and X dot. This X dot is free radical. And I have already told you free radical is what? 7 electron, that is odd electron species. 1 degree, 2 degree will do combination, 3 degree will do disproportion for alkyl group. First step is chain initiation. Second step is chain propagation. Chain propagation. Chain propagation. Chain propagation, you have to understood this chain propagation is a exothermic reaction. Which types of reaction the chain propagation is? Exothermic. 3 steps this reaction will happen. What happen in the chain propagation? Suppose we have CH4 and free radical I have got X dot. What will happen? The hydrogen from here, CH, one hydrogen will do free radical because hydrogen is more stable with chlorine or bromine or iodine instead of carbon. And because of that you will get CH3 dot and halogen dot and hydrogen dot will form HX. Now CH3 dot is getting angry. You have taken my girlfriend. I will destroy it. It will take another X molecules. They will do their homolytic cleavage and dot dot, one dot will coming here, CH3X plus X dot. Now this process will be in the continuous way. Coming like that it will happen until and unless all the CH4 and all the X, that is chlorine, bromine, iodine, not converted to CH3X. Once it will be converted, then we have to go with the third step, and that step is known as chain termination. This is the fixed step that you have to know what is happening. Understood? Na? Chain termination means you have to check. In the first step, I got X dot. In the second step, X dot. And one more dot is CS3 dot. It means how many dot we have got? One dot is CS3 dot. One dot is X dot. Any confusion in that? Now, what will... Over here, we will take CS3 dot, X dot is there. What will happen? It may be that X dot react with X dot and it is forming X2. It may be that CS3 dot react with X dot and it will form CH3X, or it may be CS3 dot react with CS3 dot and it will form CH3, that is C2H6. I've understood the point. Whenever I have written this reaction over here, whenever I have written this reaction over there, in that reaction CH4 is there, X2 is there, CH3X is there, HX is there. Any place CH3 is there? No. But whenever, understood what I am trying to say? Means I am saying that whenever you have done over here this, what you are getting? X2. Over here, X2 is present in this reaction. CH3X. Over here, CH3X is present. But CH3, any place present over here? Because I am doing the mechanism for this reaction only. No sir, not present. It means this CH3 is the intermediate product. That product will come in the intermediate and going outside. Sir, didn't understood it. Don't worry. Now on this basis, two types of question will come. One question has been asked in NEET 2024. This question is, which of the following is the step of free radical mechanism? Which of the following is the step of free radical mechanism? First option given, chain initiation. Second option given, chain propagation. Third option given, chain termination. And fourth option given, all of the above. Which option you will take? Sir, just now we have seen chain initiation, chain propagation and chain termination. All three steps are the steps of free radical. This is the answer. Second type of question they will ask, that is JEE Mains question. In that JEE Mains question, what they will ask, suppose they will give you C4H10 plus Cl2 in presence of H mu or photon or sunlight. It is forming C4H9 Cl plus HCl. What is the intermediate of this? What is the intermediate of this reaction? So do one thing. C4H10 is there. Make C4H9 another C4H9. It will become C8H18. Suppose they have given C10H22 in presence of X2H mu and they are saying C10H21X plus HX. What is the intermediate? What you will do? C10H21 bond C10H21, that is C20H42. It means if they will ask intermediate, whatever be the things over here given, over here always they will give alkane CnH2n plus 2. Over here always they will give alkane. So what you will have to do? First you have to make this alkyl plus 1 and another alkyl you have to add CnH2n plus 1. Understood the point? Everyone? It means double you have to do with that after removing one hydrogen. So I hope you understood the part that is called free radical mechanism. And again I am saying, not understanding, see it the part very properly, which types of question is coming, what I am trying to dictate. Understood? See it. Once again, if confusion, then I will go the further and I will dictate some reactions on this basis. Now if I will write one example, suppose I have written CH4 Over here I am taking CH4, you can take anything. C2H6, C3H7, C3H8, C4H10, C5H12, anything. And I am reacting it with chlorine in presence of H mu or photon or sunlight. What you will say? Sir, it is coming CH3Cl plus HCl without any doubt. Suppose you have taken CH4 in presence of Br2, H mu, photon or sunlight. What you will say? Sir, it will come CH3Br plus HBr. Suppose I am saying, I have written CH4 plus F2 in presence of H mu, photon or sunlight. Then over there you can't say ki CH3F plus HF. Nah. If you will try to do, it will become explosion. Bomb blast will happen. It means fluorine will not do free radical mechanism with alkane. It will do bomb blast. Next, if I will say कि I am taking iodine CH4 plus I2 in presence of H mu, photon or sunlight, what will happen? It will form CH3I plus HI. But in this case, there is a biggest problem. What is the biggest problem? HI is very good reducing agent. What is reducing agent? If I will say LIC agent, LIC agent means those who will do the LIC of other person. The reducing agent means those who will reduce other and oxidized itself. Reducing agent means reduced other and oxidized itself. And we know that reduction is removal of hydrogen, addition of hydrogen, and oxidation is removal of hydrogen. So what it will do? It wants to return back the reaction. So I will get I2 again, I will remove the hydrogen from myself and I will reduce it. It means problem is that this reaction can't proceed forward. This reaction cannot go forward. So we are not able to produce CH3I. So what I will do over here? So what I am doing? I have taken CH4. Okay. I have taken I2. I have taken H mu, photon and sunlight. But along with that, I will take HNO3 or HiO4 in the case of iodine. In the case of iodine, because these two are very good oxidizing agent. They will say, Acha bhaiya, you want to reduce other and I want to oxidize other. Do one thing, don't reduce this reaction back. You will reduce with me. And after reduction, what happens? CH4, CH3I to coming. But HI converted into I2 plus H2O plus NO2. This is not important, but important is that HI is disturbing the problem. Now it will not disturb. So they will ask the question, what will happen whenever CH4 react with iodine in presence of sunlight? Does this reaction will go forward? You will say no. We have to use some strong oxidizing agent like HNO3 or HiO4. So it will oxidize HI into I2 plus H2O and NO2. So the reaction will go forward. Any problem in that? Sure, short? Yes, sir. Now understood everything. Now come to the next part. Over here, you are getting F dot. You are getting Cl dot whenever you are reacting F2, Cl2, Br2, I2. You are getting Br dot and you are getting I dot. Over here you will say this is the stability of free radical. This is the stability of free radical. Why the stability of free radical? Due to size. Iodine is very bigger size, so they can easily handle free radical on them. Now try to understand. Up to now any confusion? No confusion, sir. Now try to understand something about F dot, I dot, Cl dot and Br dot. This topic is very important. So I am saying if you are not getting anything, try to see it once again from the beginning. Trust me, it will become very easy for you because halogenation is bigger topic. After that the topic is very smaller. Now suppose you will see one place F dot, another place I dot, another place Cl dot, another place Br dot. These are the dots. Now F dot is very less stable because of size. If it is less stable, so it is highly reactive, means more reactive. As it is more reactive, so it is highly exothermic. More reactive, so it is highly exothermic. And it is highly exothermic, so not done by free radical. So you will see na explosion is coming. I have written you ki in case of fluorine explosion will come. Second part, I dot. I dot is highly stable. And it is highly stable, so it is very less reactive. It is very less reactive, so we have to use, what we are using, HNO3 or HiO4 as oxidizing agent to reduced Hi. Understood the point? To oxidize Hi, sorry. To oxidizing agent to oxidized Hi. Oxidized Hi. This important point. Now, Cl is less stable, not that much stable, not more stable, not less stable, intermediate stable. Less stable means more reactive. If more reactive is there, then it is less selective. And for that, we have to know their selectivity ratio. What do you mean by that? Just wait, I will dictate. For that, we have to know their selectivity ratio. What is selectivity ratio? For 1 degree, the selectivity ratio for 1 degree is 1. For 2 degree, it is 3.8. And for 3 degree, it is 4.5. What you have written over here, sir? We didn't understood. Just wait. I will dictate you by writing the example. Now, bromine. What you will call about bromine? Bromine is more stable. And due to more stability, it is less reactive. As well as it is less selective also. So, their selectivity ratio is coming something like that. 1 degree, 1. 2 degree, 81. 3 degree, 1600. Sir, what you have written, we didn't understood it. Just wait. Patience. You will just see it. What do you mean by that? Suppose whenever I am writing like this, CH4 plus, or in place of CH4, I will take something different. Suppose I will write C4H10 plus Cl2 in presence of H mu, photon or sunlight. What you are saying, sir? It will form C4H9Cl plus HCl. Intermediate is C4H9 dot C4H9. So intermediate I am not going to write again and again. Suppose I have taken the same thing. Over here I have taken Br2. So what you are getting the product? You are getting the product over here as C4H9Br plus HCl. Same C4H10, F2 and sunlight photon. You are saying, sir, it will do explosion. And whenever I have taken same thing and over here I2, then you are saying sunlight, so we will take, as well as HNO3, HiO4 we will take, and it will form C4H9I plus I2 plus NO2 plus H2O. Like that you are doing the reaction. But in place of that, I have written something like this. 1, 2, 3, 4. Not C4H10. I have drawn the structure. And then I will say, react with F2 in presence of H mu, photon or sunlight. So what you will say? Sir, it will do explosion. Same I will say, okay. Here explosion, react with I2. What you will say? I will take H mu, photon or sunlight, plus I will take HNO3, HiO4. Now over here, don't say only one product. This is 1 degree. This is 2 degree. This is 2 degree. This is 1 degree. At 1 degree, any one place, you will put 1 iodine. Plus, at 2 degree, at any one place, you will put iodine. So whenever different structure bond line given, then only one product will not come. If 3 degree is there, 3 degree product will also come. So now in this case, they will ask which one is the major product. So if iodine is written and bromine is written, always you will say कि 3 degree is major, then 2 degree, then 1 degree. This is the decision for major product. So over here it is 2 degree. Major means which one is coming in more quantity, and this is the minor product. But in the same reaction, suppose anyone has written bromine, what you will say? Acha sir, H mu, photon or sunlight, it will also form the product like iodine, bromine here and over here bromine, and I will say ki sir, this will be our minor product and this will be our major product. But when they will write sir, na, do in the case of chlorine in presence of H mu, photon or sunlight, then you can't say कि 2 degree is measured, 3 degree is measured, 1 degree is measured. No. First you will make the product 1, 2, 3, 4. Here Cl, 1, 2, 3, 4. Here Cl, and then you have to use the selectivity ratio. The selectivity ratio of chlorine for 1 degree, 2 degree and 3 degree is 1. Over here 3.8 and over here 4.5. Means what you have to do, you have to check the original structure. In the original structure, how many 1 degree carbon is there? Sir, 2 1 degree carbon. In that 1 degree carbon, how many hydrogen is there? Sir, 6 hydrogen is there. So 1 degree carbon has 6 hydrogen. So 1 degree carbon has 6 hydrogen. So 6 into selectivity ratio is 1, coming 6. And 2 degree carbon has how many hydrogen? Sir, here 2 hydrogen, here 2 hydrogen, 4 hydrogen, and selectivity ratio is 3.8. So 4 8 ja 32, 3 is the carry, 4 3 ja 12, 13, 14, 15. So 15.2, which one is coming more? 15.2. So here 2 degree will be the major and 1 degree will be the minor. Acha sir, so always to coming 2 degree major na. See, I am writing another example. O, Re, P, Ya, and here I have put here. Now I will say I am going to react this compound with F2 in presence of H mu, photon or sunlight. What you will say? It will do explosion. I am going to react with Br2 in presence of H mu, photon or sunlight. What you will say? Sir, this is 1 degree, this is 1 degree, this is 1 degree, this is 2 degree, this is 2 degree. Any one place 1 degree, you will put 1 chlorine. Don't say that this 2 1 degree is different. No. In this reaction, just put any one place. Suppose 1, 2, 3, 4, 5. Here you will put bromine, one possibility. Another 1, 2, 3, 4, 5. Here you will put bromine on 2 degree. And one possibility that another product you will make 1, 2, 3, 4, 5. Here you will put bromine. If anybody is asking what is the major, so 3 degree will be major in case of bromine and 1 degree will be the minor. What about 2 degree? No one will ask the 2 degree about. They will only ask how many product. You will say these are the product. But if they have written iodine in presence of H mu, so you have to add over here HNO3, HiO4. Same product you will get 1, 2, 3, 4, 5. Iodine over here 1, 2, 3, 4, 5. Iodine over here 1, 2, 3, 4, 5. Iodine over here, this will coming as the major product 3 degree. This is coming as a minor product 2 degree. But if they have given chlorine in presence of H mu, the first you will make the product 1, 2, 3, 4. Over here chlorine, another product 1, 2, 3, 4, 5. Over here chlorine 1, 2, 3, 4, 5. Over here chlorine. Now in the original structure check how many 1 degree? Sir, 1, 2, 3. 3 1 degree carbon. In that 1 degree how many hydrogen? Sir, 3, 3, 6, 3. 9 hydrogen is there. So 9 into 1 degree selectivity value is 1. Here written selectivity ratio for 1 degree is 1, 2 degree is 3.8 and 3 degree is 4.1. So 9 into 1 is 9. How many 2 degree hydrogen, sir? Over here only one place and 2 hydrogen is there. So 2 into 3.8. that is 7.6. How many 3 degree hydrogen, sir? Only one 3 degree and only one hydrogen is there. So 1 into 5. So in this case, which one is major? Now previously 3 degree is major for chlorine, but now 1 degree is coming major because it is the major value, and 3 degree is coming minor. So for chlorine, you can't say directly 1 degree, 2 degree, 3 degree major or minor, something like that. Understood? Everyone? Sure, short? Ha, sir. Understood. So see it very properly. If any confusion, you can ask me. So this is all about selectivity ratio that I have written the point. Over here, you are getting two problem. One problem you are getting in the preparation of two problem, and I am teaching organic chemistry in that way that whenever the problem is coming, first I will sort out that problem. One problem for the preparation of alkyl fluoride. Alkyl fluoride. You are not able to do. What happens? Explosion happen. What happen? Explosion. So to overcome this problem, we will use one reaction, and that is called Finkel-Stein reaction. That is called Finkel-Stein reaction. Detailing we will have to do in alkyl and aryl halide. Over here, just I am writing Finkel-Stein reaction is also known as halogen Finkel-Stein, not Schwarz reaction. Finkel-Stein for iodide. Over here you are getting the problem in the case of producing the alkyl fluoride, explosion coming, and this problem has been sorted out by Schwarz reaction. This problem has been sorted out by Schwarz reaction, and what he is saying, this method is also known as halogen exchange method. This method is also known as halogen exchange method. Halogen exchange method is saying कि first you will prepare either alkyl chloride or you will prepare either alkyl bromide by free radical mechanism. Once you will prepare alkyl chloride or alkyl bromide, so in place of that I will write directly Rx. X will be either chlorine or bromine. What you will do? You will react this with either AgF or you will react this with either Hg2F2 or you will react this either COF2 or you will react with SbF3. After reacting, what you will get? RF, here also RF, here also RF, here also RF. Over here you will get AgX, over here you will get Hg2X2 because Hg2F2 is there. So Hg2F2. Over here also you will get COX2. Over here you will get XbX3. So fluorine is not prepared. Two problem is coming. One problem is coming. That problem is we have to use HNO3, HiO3 for that. So I am just dictating one problem only over here. Second problem I will dictate in alkyl and aryl halide. Not that much important, and you have to understood each and everything. This chapter is already very big, so I will add all this over here. Now the preparation of alkyl fluoride is the problem. Who has sorted out that problem? Schwarz sir. And these things you have to learn as it is. As it is. Why? Because there is a NEET question. In that NEET question they have asked which of the following is not used in Schwarz reaction. Which of the following is not used in Schwarz reaction? First option they have given COF2. Second option they have given AgF. Third option they have given Hg2F2. Fourth option they have given SbF5. Now looking all same, but SbF3 is there, not SbF5. So exact reagent you have to learn. So I hope halogenation you have understood very properly. If not, then you will see it again. Halogenation part done. Then remaining part is isomerization, aromatization, pyrolysis. What are the topic? I have dictated na. Halogenation only I have dictated. After nitration, sulfonation, Reed's reaction, isomerization, aromatization, combustion, pyrolysis, everything I will cover here. It is required to cover in one video. It is good instead of 2 to 3 video. Now over here, suppose some different type of question is coming in the exam. They will ask find the, some questions I will write, find the number of monochlorination product including inducting not, including a stereoisomerism, including stereoisomerism. So what you will do, you will first suppose first question, Orapia reacting with Cl2 in presence of H mu. What you will say, sir, this all are 1 degree, this is 3 degree. So all 1 degree looking like same. So any one place I will put Cl and another product Orapia, here I will put Cl, including stereoisomers. Is there any chiral center? No sir, this is CH3, this is H and H, no chiral center is present. No chiral center is present over here. So no chiral center, it has 1, it has also no chiral center 1. The total stereoisomerism including is 2. Acha, second question, don't worry. I will write lots of questions to complete it. 1, 2, 3, 4 in presence of Cl H mu. What you will say? This is 1 degree. This is 1 degree. This is 2 degree. This is 2 degree. So 1, 2, 3. Over here you will put Cl and another option 1, 2, 3. Any one place you will put Cl. Now in this part you will say it does not have any chiral center, but this is the chiral center. So now chiral center means 2 product. 1 chiral center 2 product, 2 chiral center 4 product. The total including stereoisomerism how much coming? 3 coming. GOC, mirror image. Those who have not seen, see it. I will not dictate GOC here. Now third question. Suppose I have given like this 1, 2, 3, 4 and like this, and chlorine in presence of H mu. What you will say? Sir, this is 1 degree and but this 1 degree and this 1 degree is different from this. So over here you will say 1, 2, 3, 4, here 1 Cl. Another part 1, 2, 3, 4, 5, here 1 Cl. Any one place you will put. Then you will say another product 1, 2, 3, 4, 5. Here on 2 degree you will put 1 Cl. Then 1, 2, 3, 4, 5. Here on 3 degree you will put 1 Cl. Is there any chiral center over here? No sir. Over here CH3, over here CH3. No chiral center is present. Over here any chiral center? This carbon has chlorine. This carbon has hydrogen. Ha sir. This is to not chiral center. But if you will see here, it is coming chiral center. So it is giving only 1. But after coming Cl, it is coming 1 chiral center, the 2 product. Over here, any 1 chiral center is there, sir? Sir, here to no chiral center, CH3 is coming. But here it is the chiral center. So it will also give 2 product. Here any chiral center, sir? No, sir. Here no any chiral center. So only 1 product. Understanding what I am trying to say? Or not understanding? हाँ sir, understanding it. So see it very properly. So how many total coming? Sir, 2, 2, 4, 1, 5, 1, 6. The total monochlorination product including stereoisomers is 6. And this is all about the completion of the topic called halogenation. Now lots of student has messaged me कि sir, I have completed all the videos. Please can you upload the next one? So halogenation I will upload. After that aromatization, aromatization, combustion, isomerization, pyrolysis, nitration, sulfonation and reaction I will upload in the next part. Because already you are waiting for the video, so why I will leave it. Understood the point? Okay, up to this. Bye. Have a nice evening. Fourth part I will do like that. No problem. Any part will come. No any problem in that. Bye.